have for these photons, energy is going to be equal to some sort of constant, which they call h. This is another constant like r, but this is called Planck's constant, times nu. That's not a v, it's a nu. It doesn't mean velocity. It's nu. It's Greek. Right? Like neutrino, nu. Okay? That's how my teacher used to say it. You're so retarded. Anyways, this h here, 2.18 no, sorry. 6.626 times 10 to the negative 34 joules seconds. Joules seconds are the units of it. Yes. Okay. That is that constant. That is h. And nu, this right here is frequency. This is the frequency that it's oscillating at. What are the units of frequency?
Hertz.
Hertz. What is a hertz?
Cycles per second.
Cycles per second, or otherwise 1 over seconds. Okay. So frequencies, the units of these guys are 1 over seconds, or if you want to, and you're familiar with it, seconds to the negative 1. Okay. Those are synonymous terms. So if you look at it, if you have a 1 over seconds times a joule seconds, seconds cancel out and you're left with joules, which is energy. So that is why a hertz, or a frequency, is 1 over seconds. And also, if you go through physics, you'll see it does turn out to be that. Okay. All right, so any questions on how to derive how much energy a photon has if you know its frequency? So, all right, the next thing you need to know is that frequency is equal to the speed of light, which is c, divided by the wavelength, which is lambda. So this right here is speed of light. Speed of light. What number is that? If you want to say 3.0, that's fine. 2.99 times 10 to the 8 meters per second is your speed of light. Lambda is the wavelength. And this is in meters. Okay? That's in meters. So look at this though. We could plug this, since this is new and there's a new there, we could plug this in for that, right? And so if we take these two and bring them together, we have energy then is equal to this Planck's constant times the speed of light divided by the wavelength. So if I said to you, calculate the amount of energy that the color blue has. The color blue is approximately 450 nanometers in length as far as the wavelength. Calculate that real quick for blue, and then calculate it for red. So blue, its wavelength is 500?
500 nanometers.
Yeah, I was going to say 450, but it's fine. 450 nanometers. And then for red,
700.
yeah, 700 is the one for red. So calculate how much energy there was for those wavelengths. How much energy was needed for those wavelengths? Yeah, was it a was this your paper too?
Energy.
No?
Yeah, that's mine.
Correct, grab it.
Is it a certificate?
You sure this is it? There's also these things here. Check those two, because I was there too. So you have this.
Oh, that's not mine.
Was it this one? Good? Alright, so let's see how you do this. So what's the first thing you need to do? Make it into meters, right. Conversion first needs to go to meters. Because what's it say wavelength needs to be in? Meters. Let's go ahead and work with the C, which is in meters. Speed of light is in meters. So you have to convert these to meters first. So this blue being converted to meters is what? How many meters? 450 times 10 to the negative 9. What's negative 6? Micro. And then this one would be 700 times 10 to the negative 9 meters as well. Good, that's the first step you have. Plug these in to here. You know these values here. So for the first one, energy is equal to 6.626 times 10 to the negative 34 joules seconds times the speed of light. Divided by the wavelength. And what's that for the answer? Blue? Huh?
Oh, I didn't convert the first one.
Okay.
So.
I got 4.40 times 10 to the negative 37.
Okay. Double check that again. One more time. Okay, so I got 4.40 for the blue one. The energy for the blue that was needed was 4.40, if I want to be sig fixed, times 10 to the negative 19 joules. That's how much energy the blue light wave has. The red light waves, energy of the red, do you expect it to be more or less? Is it higher or lower energy? It's supposed to be less, right? And I got 2.83 times 10 to the negative 19 joules. Is that less? Kelsey, good?